Hello and welcome back. In this session, we are going to learn polymorphism and dynamic binding. So for that, we have nice program here that we're going to write. And this time, it's been a while that we have only written a skeleton. So this time, let's just write fully runnable program. Okay. If you happen to see videos in between, like something from the middle, and probably you know I would like to create sort of chances that you land with one of the fully runnable program. In that way you don't confuse. You can just, if you're new to Scala, you should be able to run the program and see, because there is a fun in writing a complete program and running it. Having said that, let's get started with our animal sound app Scala, or I might say animal sound dot Scala. I just want to give you the feeling that the name, file name here, and then object name inside the file, so they don't have to be same. If you're learning programming language like Java, for example, your class name and your file name should be same. Right? At least that's true up to Java 1.8, 1.9 probably. Okay, let's not worry about that. Ready, save number. Right, so now we're ready to type program, and my class is going to be animal. It's very interesting. Okay, animal have name, and I have a definition here, make sound, and the parameter, nothing to return. And what does it do? It just prints something so that we know that it is working or it is not working. Okay, and that's going to be abstract sound. Okay, that's it. Okay, when this is invoked, we get something printed, some message printed, so that we know that we are in the animal class, abstract class. I mean abstract sound here. Okay, because animal is just animal, it's abstract thing. Right? Even though I don't have an abstract keyword here, it can be instant. This class can be instantiated, but this is more like conceptual kind of thing, right? I mean, animal is a more like an abstract thing, unless I say like cat, cow, dog, Right. So now we define more specific thing, and that's going to be name string, and I might take, well, I may not take this. That's it. Extends animal. I'm going to pass whatever I have here. And now that's it. Override. Okay, because I extended, I need to override. I mean, I have the option to override. I don't have to necessarily override because it's not abstract. Sound. Okay, and then I don't have anything interesting to return. So I'm again going to println name plus, and then I'm going to say cat does meow. Okay, class, I have a cow, has a name, have a string that extends animal, which takes name, and then I define it. Very easy, very easy. And I'm again overriding it. Override def make sound. Okay, unique is equal to this one, println name. Okay, now probably you've got the intuition here what I'm going to write, right? Ready. One more. We're going to do one more. Doc. That also going to take name, and that extends animal because dog is an animal. and animal text name, animal have name, right? Then we're going to override again. Def make sound. Now you can complete it yourself, but I'm just going to do that here for the sake of completing it. Println, you have name plus in the code I have a quarks, right? Now let's create the application object animal sound app. Please note that my object name and the file name here, which is this one over here, right here, animal sound, are not same. They don't have to be same. Okay, you don't have to be confused. Args array string unit is equal to this, and how many parentheses I have? Ready? Now make animal sound. Well, first of all, let me not do that here. Let me do write later, or I could say to do. Okay, and I'm going to define one more method here. Make animal sound. This is going to take animal type, could be any, returns nothing, and body would be like animal dot make sound, because all of them have sound. Again, we haven't specified which. Now I'm going to write it back here, right? And in that method, make animal sound in line number 30, we haven't specified anything very specific. It's going to be very reusable, and we'll see how we can use it. Make animal sound. Okay, now if I pass new animal, animal type, the abstract superclass is going to give me, it's going to call that method of that superclass, and make animal sound. If I say new cat, and then here I say some name, okay, cat, then it's going to call this make sound method of the cat class. Okay, similarly, now you must be guessing it correctly, what I'm going to write. That's going to be cow, and again cow, right? I need to provide suitable name, and the last one, make animal sound, is going to be new duck, and I'm going to pass duck. Okay, that's it. So save and quit, and then let's run it. Alright, let's see how many errors we get. Any errors is expected. I had one F over here in line number 3, and then line number 26. Line number 3 and line number 26. Okay, remember that. Line number 3. Oh, I don't have lines here. Very interesting. Line number 3 and line number 26. 3. What do I have in 3? One extra F here. I don't need that. And line number 26, what I have? I don't have a complete name, right? The complete name over there. So I'm saving it, quitting it, and rerunning. Before that, I might like to clear the screen so that you see the clear output over there. Oh, why do I have that thing over there? Hey, why did I? Well, I did not particularly like that. Let me go to the editor and see where that where that things comes from. Okay, do I have any slash here? I don't have any slash here. Let me run it one more time. Okay, right, abstract. It went to abstract sound, cat, meow, cow, moo, and dog quack. Already? Now it's a beautiful polymorphism. So how did that happen? Let's go back to the class before we end this video. I didn't mean that. All right, see. Okay, let's have our line numbers there. Line number 1 to 5, you see the class animal is being defined. It has a make sound method and it has some string to be printed, and it takes that name, whatever name is passed when it is invoked, right? Similarly, cat, it extends from that one, but it overrides the method, right? And then we have this make sound, and it has a mew. So cow has moo, dog has quack, and then in my animal sound app, I have defined one make animal sound that takes a common parameter. It's making code reusable, which is type animal, because all of these cow, dog, and cat, they extend from animal, so their types, their super type is animal. So we can pass their instance from using this method, and this method does not return. So I mean, doesn't return anything interesting. That's why we have unit, and it calls animal.make sound. Okay, and all of them they have a make sound. So when I create line number 27, when I create the instance of animal, then it's going to call the corresponding method, whichever is defined inside the animal class. And then in line number 28, I am creating instance of cat, and when animal.make sound is invoked, is going to call the make sound method of the cat, not of animal, not of cow, not of dog. Okay, that's a polymorphism. Okay, so it kind of determines that during runtime, when I run it, when I create instance, when I call them, it knows where to and which one to call based on the type, because it's a typed language. Okay, sometimes we define type explicitly, sometimes type is inferred, but still it's a typed language. So now in the line number 29, I have a new cow, right? So in cow also has a make sound method. So when animal.make sound method in line number 34 is invoked, it's going to call that corresponding method in the class cow. Finally, in line number 30, I have make animal sound new dog, right? So here instance is a dog, the type is dog. So when make animal sound method is called, it goes to line number 33, calls that animal type. So it's a super type, so that's acceptable. Dog type comes here, and then it goes to animal.make sound. That call will call the make sound of the dog because the type is dog. So that basically summarizes or explains polymorphism and dynamic binding. So what is dynamic binding? Because these methods are bound during runtime. Which method to call? It's actually bound. It's actually done during the runtime. Okay, that's a delegation. Which class to go to, right? And which is corresponding instance. Polymorphism. See, there are multiple forms. Make sound. Uh, we have many forms of make sound based on the type, right? So polymorphism and dynamic binding. Okay, so that completes the explanation for polymorphism and dynamic binding in Scala for our context. I will see you in the next session with a video for composition, which is going to be our last video for this chapter, and the chapter that we are talking about is inheritance and composition.